Hello, friends of chemistry. We're finishing module 13 practice problems. Martin, what number are we doing now?
What's Jables? Jables. 9.
Please
Determine
read
the
it.
activation energy in delta H for the following reaction.
Okay.
Is drawn an acceptable sketch.
So,
Is
looking
this
at
reaction endothermic or exothermic?
Looking at this, where do we find the activation energy? What is that?
At the top of the arc.
From where? From the top of the arc
to the bottom. So
this is our
activation energy.
Okay. So what is it?
It's
what would you say it is? Look in the book.
It's 1,450 minus 200.
I think it's probably closer to 1,500. Right?
Oh yeah, that's what I meant to say.
Yeah. Okay. So minus 200 gives us 1,300 what?
Kilojoules.
So is it endo or exothermic?
It's endothermic.
Correct, because it's a positive. Okay. How about number 10? Please read that.
No, we still haven't found the delta H.
Oh, sorry. The delta H. How do we find the delta H? That's going to be the change in enthalpy.
Yeah.
Right? So here and here, right? That's what we're looking at?
Yep.
So looking at that book, because it's better than my drawing.
So I think it's about 1,300. So that's the delta H is 200 then.
What?
I think, yeah, that's it. That's right. No, not 200. Not that.
Yeah. The delta H is the difference between the H of the products minus the H of the reactants.
Okay, so it's 1,100 kilojoules.
Okay. The activation energy is 1,300 kilojoules, and it's endothermic with a delta H of 1,100 kilojoules.
Okay, on to 10. If you'd erase that.
Okay, so, no, number 10 is right here.
Okay.
Ah!
Is the following reaction spontaneous at 298 degrees Kelvin?
Okay. In order to do that, we need to use our which equation do you need to use?
13.14.
Gone too far.
The chosen one, Anakin. You meant to destroy the Sith, not join them.
So the whoops. Okay, so we say the delta G, the standard delta G, is the summation of the delta G, standard delta G of formation of the products minus the summation of the standard delta G of formation of the reactants.
Yep.
Okay, so what are these things? How can we calculate this? Similar to the delta H of formation of elements, it's going to be 0 for these, right? This is going to be
Yep.
0, and this is going to be 0. So what we need to do is we need to figure out what is the summation of the products here, which is only this one, and the reactants here, okay? So how many moles of C2H6O do we have? And the fact that it's at 298 Kelvin is very important. It tells us that we can use the table with the table 13.6 or something. Where is it? On page 447, table 13.4, the standard gives free energies of formation in kilojoules per mole of these following substances. So what is the, so C6H6 liquid, what is that?
That's.
Oh, wait, let's not do liquid yet. Sorry, C2H6O liquid.
C2H6O liquid is negative 175 Gibbs formation.
No, what are the units? It said at the top of the chart, please.
Oh, kilojoules over moles.
Okay, and minus, what is the, we have 2 moles of this, and what is that? C6H6 liquid.
Yeah.
This one, please, was C2H6O. This one, please, is C6H6.
Okay. C6H6 liquid is 125 kilojoules
This is positive?
per mole. Yep.
Okay, so moles cancel moles. So what is 6 times negative 175?
Okay. 6 times negative 175 minus 2 times 125 equals negative 1300 kilojoules.
Okay, so in order to answer the question doesn't actually ask us what is.
It is spontaneous.
Yes. It's negative, so yes. This reaction will be spontaneous at 298 degrees. Okay? We don't know if it'll be spontaneous at any other temperatures, right? We can only use this with reactions that occur at that temperature, right?
Yep.
Okay.
Catch you on the flip-flop, Jables.
Good luck on the test.
You'll need it.
Yeah, it's a tough one. Work hard. Know your equations.
Post the video.